XML is a typical document store, which is an alternative to traditional relational database management system. It provides a standard for data storage, representation, exchange, and especially for data exchange on the Internet. XML is the abbreviation of Extensible Markup Language. Markup, generally, is the tags we put on the document to serve for some specific purposes. For example, to explain part of the document or to specify which font should be used in displaying the part of the document. To formalize such markups, we create markup language. Specifically, a markup language specifies which part of the document is the content, which part of the document is the markup, and what is the semantic of the markups. That is, what does the markup mean? The set of tags we use are crucial for a markup language. Such a set could be predetermined, which means that it is fixed for some markup language. For example, hypertext markup language HTML has a fixed markup set, whereas for XML, such a set can be extended, which is to say, we can determine or define the tags ourselves to augment the set. That is why we called XML extensible. There are three basic elements or components of an XML document: tagged elements, attributes, and text. Elements serve as the building block of XML document. For each element, it may bear some attributes or texts. So in other words, XML describes the document content with tags and attributes. This is an XML document displaying the inventory of a bookstore. In this document, markups are in the forms of tags, where each tag is some text enclosed in angle brackets. For example, bookstore is a tag, and /bookstore is another tag with the same text. The tag and the / tag of the same text composes an opening and ending of an element. Such element includes bookstore, which is the largest element, book, title, authors, author, first name, last name, and so on and so forth. There are some text in this document. Here are embraced by an opening and ending tag. For example, Jeffrey, human are the text of the document. Attributes are also listed in this example. They are included in the opening tag of some elements. Such attribute could be an ISBN followed by the value, the price, the value is 85, and the edition is third. Note that for the two books, they may not have the same set of attributes. Especially for the first book, there is an edition, and for the second book, there is no edition attribute. the tags are nested properly here. They can be infinitely nested, so there will be no constraint on how deep a nest could be. And that is why XML is more flexible in relational database. Let's compare these two in this table. So for relational database, the schema of a relation is determined before we load any data. After that, the structured data is loaded into tables. A table is organized in rows or columns. When a query comes, all the data will be returned without an order, unless there is a order by clause followed by the query. On the contrary, for the XML schema, it is very flexible and not rigid. It is open to update as we go. To some sense, we call it self-documenting because it can describe itself. The structure of an XML document is hierarchical and nested. So in a way, we can see it as a tree. For example, the element of bookstore will have 2 children, 2 books, and a book will have 2 children, title and authors. If we take into consideration the references we may introduce later, the XML file can also be regarded as graphs. When a query comes, all the elements will be returned in a sequential order, though it may not be used by the user, but the order is preserved. So this is a comparison of XML and relational database. For application, at the beginning, it has to decide whether to use XML or relational database as a fundamental story, querying, and access method. In the XML document, elements serve the fundamental role. A document must have a single root element, which is the single element that encompasses all the other elements in the document. Furthermore, the tags or the elements must be nested properly. Here are 2 examples. One is proper, one is not proper. General rule is that the tag starts later must be closed earlier. For example, here A, B/B/A is correct because B comes later and it is closed earlier. Whereas A, B/A/B is not proper. The 3 requirements of an element actually forms the basic structural requirements of a well-formed XML document. Single root element, match tags, proper nesting, single value attributes within elements. For the 3rd requirement, actually it is saying that an element should be single-valued rather than multi-valued. If all the 3 requirements are satisfied, we call it a well-formed XML document. In order to automatically analyze an XML document, we have XML parsers provided. For XML parser, if we are given an XML document, we will feed it into XML parser, and the XML parser will return to us in 2 cases. If the document is well formed, then the parser will return the parsed XML, which could be a document in the form of a document object model, or if the document is not well formed, the XML parser will return the errors. Let's have a try. So the easiest way is to download the XML parser called XML link from this place, unzip the file, add the bin directory to the path of the system setting, and then validate via this command line. Let's try to look at some examples. Okay, so this is the bookstore XML document we've seen before. The first thing we're going to try is whether this document is well formed or not. So we input the command line as below. Here we want to have to see whether this document is valid. Oh, sorry, it is not validity. So first of all, we want to see whether this is well formed. We don't want to output the parsed document, so we add a parameter called no output. So let's try. There is no return. It's saying that it is well formed, so it passed the examination. Next, we'll make some updates to the document. For example, so title and /title is a pair of tags. We change this closing tag to uncapitalize the title, and then we rerun the command. It is good. It's well formed. Oh, sorry, I didn't save it just now. So another try here returns the error message. It's saying that opening and ending tag mismatch. Title line 10 and title does not match. So we change it back. Next, we're going to delete a closing tag, for example, first name, and then try the command. Okay, the command is very long. The error message is very long. Essentially, it is saying that an opening and ending tag mismatch, first name line 13 and author mismatch, because we don't have an ending tag for this first name. Let's undo it. And after that, we're going to switch the first name and last name here to verify whether the well-formed document should follow properly nested tags. Okay, so here, opening and ending tag mismatch. Okay, so it is another error. Although it seems similar, but it is actually different. We have to switch it back. Okay, so the XML file will be downloadable from the website in the package. So you can find a bookstore well-formed.xml to play with it yourself. Apart from the structural requirements, which leads to whether the document is well-formed or not, we can add some content-specific specifications. And with this specification, we can constrain the content we present in the document. To define such a specification, we use one of the two schema definition language. One is document type definition, DTD as abbreviation, or XML schema definition, which use XSD as abbreviation. We should introduce both of the language and to play with it, see how the documents can be validated by these two specifications. The method we validate an XML document is similar with the way we check whether the document is well formed. So as an input, we put XML document along with its DTD or XSD and feed them into the XML parser. We can also use XML linked here. And the parser will return two types of messages in two cases. If the document satisfies the DTD or XSD, the parser will return the parsed XML. Otherwise, it will return the errors for you to check. Let's see an example. This is a DTD of XML document we've shown you before. DTD actually is a list of rules for what pattern of sub-elements or attributes may appear within the element placed on the top of an XML document. It declares attributes and elements respectively. For example, for the element of bookstore, it is described with the regular expression of sub-elements. Here, this symbol means or, A or B. This symbol means 0 or more. So this line shows that bookstore is a list of indefinite number of book or magazines. The question mark here means 0 or 1. So the element of book includes an element of title, an element of authors, and perhaps there is an element of remark. So in order to define the attribute list of element book, we say ISBN, this is the attribute name. CData means character data. ISBN is required for a book. And similar definition here listed for the price attribute. For addition, it is a character text which is implied, which means it is optional. For the element title, it is element of pure text data, whereas element authors is one or more authors, is a list of one or more author. And the author includes one first name and a last name, where each of them is pure text. Let's try to see whether this document is valid or not. The command line is XML linked, valid, no out, okay, there is no return, which means it is valid. So let's try to modify this document. First, we should make the addition required. So in changing this, there must be a mistake because for the first book, there is an addition. Of course, it's correct. For the second book, there is no addition, which violates this required constraint. So let's try. Oh, I didn't save it. Okay, so it returns element book does not carry attribute addition. It's true. Okay, turn it back. So next, we're going to see whether the order of elements are restricted or not. So we should swap the order of an author. For example, here the author has a last name Newman and first name Jeffrey, and then we save it. Then we see whether it is valid. Okay, it returns the error say element author content does not follow the DTD, expecting first name, last name, first name. So true. The element here is ordered. The elements here are ordered. Let's undo it. And the first thing we do is to look at the remark here. So the remark is specified as an optional element, sub-element of a book. But it requires that a remark should have no more than one sub-element within one book instance. So let's try to copy this remark so that this book instance will have two remarks, and then I think it will be violating the DTD. Okay, so here follows the error. Element book contents does not follow the DTD, expecting title author remark question mark got title author remark. Okay, so that means that we are violating the rule. Let's remove it. Remove both of the remark and see if it is correct. Yes, it is correct because here is a question mark. Okay, let's restore it. Okay, so this slide actually describes the basic knowledge we need to know to read a DTD document. And we've seen the validation, and that is all for DTD, and we will move on to schema in the next slide. So the document type definition language DTD is always complained by the users because individual text elements and attributes cannot be further typed. And it is very difficult to use DTD mechanism to specify unordered sets of sub-elements. And luckily, we can use DTD to specify ID and ID references. Let's see an example. Okay, so let's look at this bookstore ID ref.xml file. So in this file, the DTD specifies several IDs and ID references. For example, for book, its attribute ISBN is an ID, which is required for a book. And for the author, its identity, ident, is an ID, which is also required. And there are two references to these IDs. One is the book ref. Okay, so attribute list of book ref has a attribute book, which is the ID ref, potentially referred to the book ID. Whereas there is another reference which is the book. Okay, each book will have a certain number of authors, and the authors are specified by ID refs, which is required. The difference between ID ref and ID refs is that ID refs is a list of ID refs separated by space. For example, so in this XML file, we have books and authors. For each book, its ISBN is its identifier, and it has a reference ID refs called authors, which is ID refs to the authors, because for each author, there will be an ID called identity. So ID authors is a list of an identity, JU and JW, for example. So let's first verify whether this document is valid or not. I think there will be no doubt about it. Okay, so there is S. Okay, so it is validated. Now let's do some modification to this document. First, I'm going to change this to HG. Note that identifier, the value of the identifier should be unique. So in doing so, we have a duplicated identifier value, and that would violate the definition. So ID ref attribute authors reference an unknown ID, and yes, the first one is element author, identity arrow, ID HG already defined. Okay, let's undo it. Okay, so the second experiment we do is to refer book references to author. Okay, so here we say there is a book ref, so generally it should be a book, but if we place author here, say HG, generally it is okay, because the ID reference that do not check whether the reference is referring to a book or the author. So let's try. Okay, it is correct. And the third experiment is to add a second reference, second book reference in remark. So because here, okay, so the reason we do this is that here remark is defined as some text and some book references repeated indefinite number of times. So here we copy the reference and then check whether it is valid. As expected, it is valid because here we have a star to indicate that the reference can be any number. Any total number of reference can be shown here. I think that will be all for this ID ref experiment. Okay, so as we can see that